So we at the Department of Aerospace Engineering are interested in things that fly or at least remain in the air for a long period of time. Anything that you can imagine, basically airplanes, helicopters, spacecraft, satellite, balloons. Our faculty and students try and understand the mechanism behind these flying objects, how to design and manufacture them. The discipline is divided into various sub-disciplines like aerodynamics, which deals with the forces which are generated because of air passing over a vehicle, propulsion, which gives thrust to the vehicle to travel up, dynamics and control, which is basically controlling the vehicle in air or in ground.
Aerodynamics deals with the motion of objects through air and the forces and the moments that the air exerts on the body as it moves through air. For a typical commercial transport aircraft carrying 400 plus people and weighing about 400 tons, the primary aerodynamic forces that one would be interested in are the lift force, which acts upwards and counteracts the weight of the aircraft, and the drag force, which acts like a penalty to moving an object through air. The primary objective of a researcher in aerodynamics would be to design objects which produce the required lift force, at the same time maintaining minimum drag levels.
The propulsion problem is to make an engine that works efficiently over a wide range of conditions. We focus on a few aspects of this complex problem. An airplane engine generates thrust by adding energy to the air flowing through the engine, and this energy comes from the combustion of a fuel. Can we generate thrust with less pollution? The combustion groups are working on improvement in the existing fuel injection strategies and novel concepts like flameless combustion to enhance the engine performance. We are also interested in understanding the combustion instabilities that can cause engine failures. Irrespective of the outside atmosphere or air, the air inside the combustor needs to be maintained at such a condition where combustion is possible, and there is only limited range where a turbo machine can meet these requirements. The turbomachinery group in our department is interested in understanding the intricate flow features of the turbo machine flows to make them more efficient and to work with larger margin.
A lot of present-day research requires simulating engineering problems on computers. Computational simulation can take an enormous amount of time even for small problems. So we often need to use multiple computers in tandem to solve some of these problems. We are broadly interested in trying to see if we can simulate these problems in a shorter amount of time with greater accuracy. We do this using two approaches. One is we use better numerical techniques that are more efficient and more accurate. The second is to use computational technology better in terms of technology like GPUs, etc. Once we have these simulations, we need to visualize the results. We also work on tools to visualize this data effectively.
Aerospace structures are driven by the twin objectives of high strength, stiffness, and lightweight. Aerospace Structures Group is responsible for physically realizing the shape or the aerodynamic shape of the aircraft under the given set of minimum weight constraints. They are also responsible for estimating the structural deflections as well as the structural strength under the given static and dynamic loading conditions. As part of the structures curriculum, students are exposed to various numerical and analytical techniques as well as in the usage of advanced aerospace materials like composites and smart materials. The branch of aeroelasticity, which involves a study of aerodynamics, controls and structures, is also covered in the structures group.
Just like any other vehicle, aerospace vehicles such as aircraft, missiles, launch vehicles and spacecraft need to be controlled. Dynamics and Control Group works to develop methodologies and tools that help in ensuring a desirable dynamical response from such aerospace and other non-aerospace systems. This is achieved through development of algorithms for navigation and guidance, simulation platforms, and control strategies. The group also has a number of experimental facilities that help in verifying and validating the ideas.
Jet engine noise is a big problem for people living near airports. There are people who are working in this department on trying to understand this problem in enough detail to then try to reduce it. What about trying to reduce the visibility of aircrafts, especially to our enemies? Aircrafts are detected using their radar signature as well as the heat generated by the engine exhaust. There are faculty members in our department who are working on trying to understand this problem and then to work on designing aircrafts to reduce this problem also.
So flight and flying has fascinated human beings from since time immemorial, ever since they looked up at the sky and saw birds flying and wanted to imitate the same. And it has been in the last 200 years that we have come to a point where powered and unpowered flight is possible, and this subject continues to make rapid advances, and this is what we are involved in as a department.